Hi, this is Prasanna from Wave Academia. Welcome to Electronics Edition. In this video, we are going to discuss how to develop integrator using op-amp in Matlab. If you look at this integrated circuit, this circuit consists of an operational amplifier which is nothing but it is IC741 and a resistor and a capacitor. The resistor is connected in the input side of the op-amp, whereas the capacitor is connected in feedback side of the operational amplifier. Make sure that the resistor is connected in inverting terminal of the integrated circuit. If you integrate a sinusoidal waveform, which will give you minus cosine waveform. If you differentiate sinusoidal, it will give you cos. But if you integrate the sinusoidal waveform, which will give you minus cos. If you look at this, this is starting from 0 and going in the negative side. Similarly, if you integrate the square waveform, which will give you a triangular waveform in the negative side. So these things we are going to discuss by today in this video. I'm straight away moving on to the Matlab. So whatever the element I'm going to use in the integrated circuit belongs to Simulink physical systems. So where to pick the elements? Go to library, go to Simscape, go to foundation library. From there, go to electrical. You are having electrical elements, sensors and sources. So go to electrical elements, take operational amplifier, capacitor and a resistor. Similarly, go to electrical sensors. I need a voltage sensor because I want to measure both input voltage as well as output voltage. Go to electrical sources. In my first part of simulation, I am going to use a sinusoidal waveform as an input. So I am choosing AC voltage source. And this one is the resistor, a capacitor, and this one is op-amp. Now I'm going to measure the AC voltage source with the voltage sensor. Therefore, I'm connecting the voltage sensor in parallel with the source. It's an integrated circuit. So I'm going to place a resistor in the input side. Now the resistor is connected to the input side. And make sure that the resistor is connected with the inverting terminal of operational amplifier. If you want to flip it from upside down, right click, go to format, go to flip block. There is no shortcut key to flip it from upside down. Use up down. Now connect it like this, and I need an electrical reference. The negative of AC voltage source is connected with the electrical reference. Similarly, positive terminal of operational amplifier is connected with the electrical reference. Now I'm going to measure the output voltage. So I'm taking one more sensor, connect it like this. Don't forget to connect the capacitor in feedback. If you want to see the output, you can use the scope, but you cannot straight away connect the voltage sensor output with the scope because these voltage sensors belongs to Simscape physical systems, whereas this Simulink, the scope belongs to Simulink. So I need a PS to Simulink converter. Okay, now this integrated circuit is ready. And the very important one more thing, you have to use solver configuration, otherwise it will throw you error. So whatever the stop time, I'm using only 0.02 seconds. Now the system is ready. You can feed your inputs. Go to AC voltage source. So whatever the peak amplitude, let it be 1 volts, and the frequency 1000 hertz. Whatever the resistor I'm using, it's a 10,000 ohms. And then the capacitor I'm using, it's a point. The capacitance is 0.01 microfarad, and the series resistance I'm using, it's a 1 micro ohm. So these are the components which I use in my circuit. Now the system is ready to run. Now if you run the system, it will give you the integrated output of sinusoidal waveform. So if you look at this, the input is a sinusoidal, and output is cosine, but it is minus cosine waveform. You can see it is starting from 0, all the values are in negative. The integration of sinusoidal is minus cosine. Similarly, you can give square waveform also as an input. How to connect square waveform? Just remove this AC voltage source. For using this square waveform, I'm going to use a component called signal builder. Okay, so this example will also give you the knowledge of how to use the signal builder. Double click the signal builder. First of all, go to access. See, whatever the stop time I'm using, it's only 0.02. Go to signal, go to go to access first, go to change time range. By default, it is showing 0 to 10. Okay, change it to 0.02. Now go to signal, go to new, go to custom. You can create your own signal. Make sure that the number of time values and number of y values are equal. Okay, so I'm starting with my time values. Let it be 0. How I'm changing the parameters? You can take this reference 0, 0.002, 004, 0.006. Accordingly, you can take the time values. Point 006, point 006, point 008, point 008, and then 0.01, 0.01. So totally, I think I'm using 11 values. Make sure that the y value is also 11. Otherwise, it will throws you error. Let beats 00. 1. Last one will be 1. So now it is both time values and y values are 11. We'll get a sinusoidal signal like this, square waveform like this. Delete the previous one. Again, go to access, change the time range. Let it be a maximum of 1. This is enough. Okay, save it, and you can close it. Again, go to stop time, change this 0.01. Now the square waveform is ready. as the input, but you cannot straight away connect this square waveform to this integrated circuit because this one belongs to signal builder, belongs to Simulink, and as well as it is not electrical signal. So you need a one more component called a constant voltage source, sorry, controlled voltage source. You're having two controlled voltage source. Okay, you're having two controlled voltage source. See, both will give you the same kind of work, but this one belongs to Simulink, whereas this one belongs to physical system. I want this one, but again you need a Simulink to PI converter, PS converter. Now this signal is straight away connected with the controlled voltage source. So from there you can take the positive and negative of your signal. Yeah, now the system is ready. We know that if you integrate the square waveform, which will give you triangular waveform like this. Run the system. Check out the output. Why we are not getting the output? Actually, the problem is I'm supposed to give the sinusoidal waveform which contains both positive of as well as negative of. Okay, but whatever the input I given, it only belongs to positive of. So I'm straight away going back to the signal. I'm doing some changes. Make sure that select this axis. Let it be, this is 0.5. And this one as minus 0.5. Similarly, this one as 0.5. So you have to select that range. This is as 0.5. This is as minus 0.5. Similarly, this one is 0.5. Okay, save it, close it. Now if you run it again, you will get the output as it is mentioned in the PPT. Look at this. So this is a square waveform. It's an input. Black one is input, whereas the red one is your output. You can see it will give you the negative output. Okay, of course, this is actually, let me take it as a VM, and this one is minus VM. So this is nothing but it is a VM. The reducing slope is VM and the increasing slope is minus VM. Okay, it is starting from 0 as it is shown in the PPT. I hope this circuit, this example will give you the clear idea of how to work with integrator as op-amp in Matlab. Thank you. Kindly subscribe to the channel. If you have any queries, kindly drop a mail to this mail ID. Thank you.